Dzień dobry Państwu. Jeszcze polskiego nie zapomniałem, ale to będzie po angielsku. I want to quickly introduce you to our plans for mission to Mars. It's a super exciting mission. I've been in a space program for 40 years, but this is one of the most exciting missions I hope to work on. So first of all, let me welcome the partners. And what is really exciting about this mission is the fact that it's kind of done in a NASA American style, where the scientists from universities, they define the science and engineers make it happen for them. So you're going to hear about all these players very soon. They are here, right here in the audience, and I'd like to welcome them. So we're going to cover these few topics in the next 8 minutes or so. It will go very fast, but then you'll have a chance to ask me questions and also the professors from the university. So when I started on the space program, spacecraft were growing in size, and they are still growing in size. I mean, they started, this was the first Jet Propulsion Lab spacecraft called Explorer 1, and Surveyor on Mars, it was about 300 pounds. Now we're talking about 6 tons. That's huge. That's huge. We're calling this Christmas tree syndrome. If you can't hang more ornaments in your Christmas tree, you buy a bigger Christmas tree. Same thing happened to computers, right? They started from medium size and they were growing in size to the point that we're filling whole rooms. But the real power of computers came when they started shrinking, when they were getting smaller. So when they came from even the size of the first PC and Mac to laptop, all the way to the things that all of you carry, right? iPhones and small smartphones, right? And what is interesting, that the same thing has been happening in parallel with the space program. The spacecraft started shrinking to the point that now we're building something that is called a CubeSat, something that is 10 centimeters by 10 centimeters by 10 centimeters, tiny little things. So Poland jumped into this business. Poland launched just recently, 3 months ago, Sat Revolution sent 2 CubeSats into space. We sent, our university sent a few CubeSats. We are in this business, and that's very smart. And why is it smart? Because all of these small spacecraft require tiny miniature technology. And all of that technology, which is in the iPhone that I have here, right? This all came from the space program. And as a matter of fact, you can see here on the top, it says camera. I was sitting in my office next to the guy who invented this tiny camera. And at that time, we weren't really sure if there will be an application. The NASA administrator asked me to build huge telescopes of the size of a stadium, soccer stadium. And why are we building the little things? Well, now we know. A lot of business, a lot of inventions come from the space program. Very well. Okay, and talking about little, just yesterday I was in Wrocław and I went to Politechnika Wrocławska and I saw something, the most amazing gadget. And I'm sorry that I don't have very good pictures of it, and I apologize to Professor Juban that I didn't get a glitzy slide from him, but he has this amazing device. If we fly this device on our mission, if this goes to space, this will pay for the entire Polish space program. These things, NASA buys for $100 million a piece. This is how much mass spectrometers cost. So I'm very excited about it. Of course, we flew 2 CubeSats already to Mars. So you may ask, okay, why are you claiming that you're the first? Why is Poland the first? Well, we are first scientific mission. The CubeSats that NASA sent were just communication devices. we got the first pictures from Mars, but they did not do any science experiments. We will have science experiments on board of our mission. And why do we decide to go to Mars? Well, there's a lot of good science to be done by small missions, and it is low cost. Now we can build these tiny CubeSats at low budget. We don't have to have NASA's budget. We don't have to have billions of dollars. I worked on missions that cost $2.5 billion. That's not the game for Poland. The game for Poland is to become the #1 nation to send interplanetary small CubeSat missions. And I think that this is extremely doable. There's a lot of good science. I talked to many Mars scientists, and they'll be very excited to send small missions. And there are a lot of compelling science that can be done. We can talk about this later. I don't want to bore you, but scientists get very excited. While waiting for the Mars sample return, they'd like to get these small missions and get new data before they wait for 6, 8, 10 years for the sample return to come back to Earth. One of the most exciting missions that Poland could do maybe is, in addition to our Mars mission, which is an orbiter, we could send with a partner a lander. And if we have magnetometers on both, we could prove there is under the surface water on Mars. This would be a scientific breakthrough. And Poland could make it. This is exciting. So what kind of mission are we planning? Well, we're planning a series of missions. Everybody knows about Apollo 11, right? But it's 11. Before it got to 11 and people landed on the moon, there were 10 other missions, right? We're also making our first mission a little less ambitious, existing technology, and then we're going to get jazzier as we go along, right? We want to use the technology that is being developed by these folks who are sitting here from Polish universities, and we're going to put them on, if it's not ready for mission 1, hey, don't worry. We'll put it on mission 2 and mission 3, because technology takes time to develop. Of course, this mission, the Mars mission, is in addition to the entire Polish space program and technology development at schools and companies. So, of course, we need these small science instruments. I worked on a mission Galileo a few years ago, and I called my dad. I don't know if you recognize the last name, but I am a son of Artur Chmielewski. And I told my dad, Dad, I'm working on these instruments for spacecraft. And he says, oh, instruments. And then you could see what ended up in one of his books. So we're going to get there on a standard Mars trajectory. It will take about 6.5, 7 months to get to Mars. And how are we going to get there? I have a partner. We're so excited that they are here. Steven from Virgin Orbit would like to tell you how we're going to launch our little Polish spacecraft to Mars and how it's going to get there.
Thank you very much, Art, and thank you to the Impact Conference, to all the esteemed members who are here today. We're very pleased to be here. My name is Steve Isley. I'm the Vice President for Business Development with Virgin Orbit, and we are excited to help revolutionize the small satellite market. Virgin Orbit is going to be the launch partner for this Mars mission, this Polish mission to Mars, which is incredibly exciting. And we use a very unique launch system, which we call Launcher One. And you may notice that Launcher One is an air-based platform that uses a Boeing 747-400 and launches a rocket from 10,000 meters into space. And we are excited for the first time to unveil that Virgin Orbit is now not only doing low Earth orbit missions, but we are also participating and will be contributing to amazing science and exploration beyond low Earth orbit into other planets, including Mars. And again, we're very excited to be here as a part of the consortium. Very briefly, so our rocket is a 2-stage rocket. It consists of a liquid oxygen kerosene rocket model. We will use a highly energetic third stage that will transport the CubeSat with our partner Sat Revolution to Mars. And this is depicted here. It is contained within the fairing, and no extra modifications to the plane are necessary. So as part of this revolution, we stand here today with a lot of new technology, a lot of futuristic technology. The future of space exploration can now be done in smaller packages. That means small satellites and small launch vehicles. So finally, I just want to show you one image of what we're doing in our factory. Virgin Orbit is proud to be part of this mission. We hope to launch the mission in as soon as 3 years from practically today. And we're busy working on our rockets in the factory, and we're busy getting together with the consortium to begin the planning and to begin the mission analysis. So again, we're proud to be here today. We're proud to make history with Poland and with Polish companies and Polish universities. And Virgin Orbit is incredibly pleased to be able to support this historic mission. Thank you very much.
Thank you, Stephen. Don't worry, we're almost done. So I was at this factory just a few days ago, and I tell you, I have never seen the cleanest factory in my life. This is, I mean, if your foot drops on the floor, you just pick it up and eat it. And this is a spacecraft, and this is a rocket factory. It's amazing. So what I just wanted to tell you is that I'm very excited. We want to go to Mars. We have very good consortium, and we want to fly the first mission. Then we want to go on to other missions and progressively put more new technology from universities, new Polish science instruments on our missions. And I want Poland this way to become the leading nation in interplanetary CubeSats. Dziękuję Państwu bardzo. Będziemy mieli jeszcze parę pytań dla naszych tutaj wspaniałych gości, a na razie Państwu dziękuję.